Hi everybody, hi. So these are going to be the solutions to the practice quiz on limits. Hopefully you watched the Khan Academy thing and then you watched my video and then did some practicing on your own. Okay, the general idea is this. Remember, as x approaches this number, well, if x is allowed to equal 2, we would have division by 0, which is undefined. So with all of these, the idea is to get the denominator to not go to 0 as x goes to whatever number is given. So, and it's going to involve factoring, multiplying, that kind of thing. These two are real simple. I wrote these problems, that's why. Okay, so this is just a difference of perfect squares. So I can reduce this function just by factoring x plus 2x minus 2 member conjugates, right? When you multiply those conjugates, when I FOIL this, the middle term goes away. Okay, so difference of perfect squares. I like parentheses on my binomials. So these x minus 2's are going to cancel, and I have the limit as x goes to 2 of x plus 2. So once I don't have to worry about division by 0, I just let x equal that number. 2 plus 2 is just 4. Okay? This one is going to be similar. Obviously, I can't let x equal negative 3 because negative 3 plus 3 is 0. Division by 0 is not defined. So, just like with the previous problem, I'm just going to factor. And again, it's a difference of perfect squares. Here the x plus 3's cancel. So I have the limit as x goes to negative 3 of x minus 3. Negative 3 minus 3 is just negative 6. Okay, the next one is similar kind of deal, but the factoring, you have to maybe put a little more thought into it. Not a lot. Okay, this trinomial, a lot of students factor it incorrectly. I don't know. I guess people just kind of jump and say, okay, it's going to be 6 and 1. But it's not, because 6 and 1, whether you're adding or subtracting, well, this is positive, so I know that the middle sign of both of the binomials, once I factor it, are going to have to be the same. So this is actually going to be negative 2 and negative 3. Again, let this be your launch pad. I always make them so they work. Okay, so if I want to make it easy on myself, okay, and I have to factor this top one, start off with this factor because they're going to end up canceling. And then you can back into the second factor. So remember, whatever's here times whatever here is here gives you this first term. So the only way that's happening is x and x. Whatever goes here when I multiply it by this negative 3 has to give me a positive 6. So that has to be a negative 2. And then if you want to check it, this gives you, when I multiply these two, you get negative 2x. And here you have negative 3x. Like terms, when I combine them, give me negative 5x. But again, just let that be like your first factor. It just makes it easier. Okay, so now that that's gone, I can let x equal 3. 3 minus 2 equals 1. Okay. Okay, now this one is similar to problems 1 and 2, and I again have a difference of perfect squares. This time it's in the bottom. So this is the one that's going to get factored. So I let x plus 4 be my first factor, and then back into it. So x times gives you x squared, and what times 4 gives you negative 16 is negative 4. conjugates. Middle term is going to cancel. You'd have a negative 4x and a 4x, no middle term. Okay, now keep in mind, okay, I'm saying x plus 4 goes into here once, goes into here once. So you are going to have a 1 on the top. So it's 1 over x minus 4. So if I replace this x with a negative 4, I'm going to have 1 over negative 8. Remember again, it doesn't matter where the minus sign lands, okay? It's wherever your hand puts it.